In this session, we're going to explore circles. We'll start with the definition of a circle. A circle, which I'm going to underline because that's what I'm defining. A circle is a set of points that are equidistant to a given point. The given point is the center, and the distance is the radius. As far as I'm concerned, that's the fullest definition of a circle we need. Notice we're talking about a set of points equidistant. Equidistant means they're all the same distance. And here I have a picture of a circle, and let me get this a little bit bigger here. And what we see here is we have a center and we have a distance, and what makes it a circle is that distance is the same distance all the way around, right? No matter where I draw the line to the edge at, it'll always be the same length of a line. And here I can see that the distance is 3. So if we consider a point that's on a circle, say x comma y, and the center of the circle, which in this case is 0 comma 0, what we're saying is that the distance is always equal to the radius, which in this case is 3. So if we turn this into a right triangle, then we can apply the Pythagorean theorem. Alternatively, we can just consider the distance formula itself. Remember that the distance formula is the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. In this case, the distance is 3, and x2 is the generic x, minus 0, well, forget it, it's just x squared, plus y2 is the generic y, minus 0 again, forget that, it's squared. And squaring both sides, flipping the thing around, we get x squared plus y squared is equal to 9. And that's the equation of a circle whose center is at the origin. Notice that this is the exact same equation we would have gotten using the Pythagorean theorem, and x squared plus y squared is equal to 3 squared. What if the center isn't at the origin? That is, suppose instead of being at 0, 0, the center was at some random set of coordinates h comma k. Then fleshing out the distance formula again with, say, a generic radius of r, we would have r is equal to the distance between the 2 points. So that would be the square root of x minus h, the quantity squared, plus y minus k, the quantity squared. And doing the same thing we did before, squaring both sides and flipping the thing around, we'd end up with x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to r squared. And for a circle with this equation, which by the way is in standard form, this circle has a center of hk, as we saw a moment ago, and a radius of r. Notice that we had to square root the r squared to get the radius. Let's look at our first example. Sketch the graph of x minus 3, the quantity squared, plus y plus 4, the quantity squared, is equal to 25. And I notice that this is in standard form. And when the equation of a circle is in standard form, it's relatively quick and easy to get the center and the radius. The center is 3, negative 4, and the radius is 5. Let's pause for a moment to talk about this. Standard form was x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to r squared. Two things I want to point out about this. One is, because this is x minus h and this is y minus k, we're going to change the signs on what we see in those parentheses. So where this is x minus 3, what's being subtracted is 3. Just like x minus h has h being subtracted. In y plus 4, what's actually being subtracted is a negative 4. That's how you're going to get a plus, right? Let me just repeat. We're going to change the signs on what we see inside the parentheses when we have the equation of a circle in standard form. The second thing I want to point out is that it's r squared on the other side of the equation. And so if I see that the radius squared is 25, that must mean that the radius itself is 5. Well, now that I have the center and the radius, I can go ahead and sketch the graph of the circle. So here I have my set of axes, and let me label the coordinates 3 and 1, 2, 3, negative 4. So that's going to be our center, and then the radius is 5. So, oh, I see, I put the 3 in a bad spot. Let me move that. There. So from the center, we can go 5 units up, 5 units down, 5 units to the right, and 5 units to the left. Oh, that's in a bad spot too. Ah, well. And then do our best to flesh out an actual circle. I'll be the first to tell you, I'm not so good at drawing circles on paper. But I give it my best shot, and then to make it abundantly clear to the world what's going on here, I'm going to write down that the center is at 3, negative 4, and that the radius here is 5. Now let's look at a picture of what we're actually supposed to have drawn. Notice it's in the shape of a circle. Surprising, isn't it? On to the next. Here we're asked to find the center and radius of a circle given by x squared plus y squared plus 6x minus 4y plus 9 is equal to 0. And this is in what's called general form. That is, there's a bunch of stuff on one side and the other side is equal to 0. So in order to come up with the center and radius, I'd like to turn what's in general form into standard form. And remember, standard form is x minus h the quantity squared plus y minus k the quantity squared is equal to r squared. Notice in the standard form we have quantity squared. It's twice, but we have quantity squared. So in short, to get the equation that's in general form into standard form, we're going to complete the square. And we're going to do it twice. So I'm going to complete the square on x. Before I do that, I want to get the x terms together. So x squared plus 6x. And as you recall from completing the square, we're going to be adding a number. So I'm going to leave a little gap. Y squared minus 4y. Put the y's together because I'm going to complete the square on y. Is equal to negative 9. Again, leaving a gap for what I'm going to add. So what we're looking at to complete the square is the linear factor on x, which is 6. Half of 6 is 3. Square that. We get 9. Remember, we have to add whatever we're adding to both sides. And then for the y terms, the linear coefficient is negative 4. Half of that is negative 2. Square it, we get back 4. And so I'm going to add 4 to both sides. And here we have, when we factor, x plus 3, the quantity squared, plus y minus 2, the quantity squared, is equal to, simplifying the right-hand side gives me simply 4. So to find the center and the radius, we change the sign on the numbers that are inside the parentheses. So the center is negative 3, 2, and the radius is the square root of what I have on the right-hand side. Square root of 4 is 2. So the center is negative 3, 2, and the radius is 2. I suppose for good form I should show you my attempt at drawing this circle. So let me get some axes, and I'll label the coordinates negative 3 and 2. And there's my center, negative 3, 2. With a radius of 2, that means we're going to go down 2, to the right 2, up 2, and to the left 2 from the center there. And then do my best to draw a circle. As I said, I'm not so great at this. I guess that means you don't have to be either. But notice when I draw my circle, I'm not drawing it to where it looks like a square or a rectangle or something, right? At least make it look like it, is trying to be a circle. And here I have a radius that's equal to 2. Let me get a different color there. R is equal to 2. And we have a center at negative 3, 2. And if you can do that for me, I'll be happy. Okay, so here we have what we're supposed to be looking at. Let me zoom that in a bit. And we can see here that, notice that the radius is 2, and the y-coordinate of the center was also 2. And so this circle actually touches an axis. In other words, this x-axis is tangent to the circle. And so sometimes in a book they'll tell you that a circle is tangent to an axis, and they'll give you the center, and what they're doing is, in disguise, they're giving you the radius of the circle. For our last example, we're asked to find the equation of the circle with endpoints of a diameter at 1, 4 and negative 3, 2. So just a quick sketch here. 1, 4 is maybe, it's in the first quadrant, and negative 3, 2 is in the second quadrant. Here's the idea. Those are endpoints of a diameter. So ostensibly there exists a circle that has that line cutting through it, right? So we need two things in order to come up with the equation of a circle. And hopefully you're already guessing. We need the center and we need the radius. Because standard form of the equation of a circle is x minus h, the quantity squared, plus y minus k, the quantity squared, is equal to r squared. In other words, once I know what h and k and r are, then I can put them into this equation and be done with it. So, how am I going to find the center? As it turns out, the center happens to be the midpoint of the diameter. So let's recall the midpoint formula. The midpoint formula is the average of the x-coordinates and the average of the y-coordinates. So parenthesis x1 plus x2 all divided by 2, comma, y1 plus y2 all divided by 2. That midpoint is going to give us the desired h and k. But what about the radius? For the radius, I'll need the distance, say the distance between the center and one of the endpoints of the diameter. Alternatively, if I wanted to, I could use the whole diameter and cut it in half, but there's a pitfall there that I'll alert you to in a few minutes. First, let's remind ourselves of the distance formula. So d is equal to the square root of x2 minus x1, the quantity squared, plus y2 minus y1, the quantity squared. And maybe a road map is in order here. So in order to find the equation of a circle, given the endpoints of a diameter, first we're going to find the midpoint. That is the center of the circle. And then we're going to use the midpoint that we find to find the radius. Once I have the midpoint, which is the center, and the radius, then I have everything I need for the equation of a circle. Let's have at it. In this case, the midpoint is going to be x1 plus x2, that's 1 minus 3 all over 2, comma, y1 plus y2, that's 4 plus 2 all over 2. And so the midpoint, God, I wish they had an abbreviation for that. 1 minus 3 over 2 is negative 1. 4 plus 2 over 2 is 3. That midpoint is the center HK. Now to find the radius. The radius is going to be the distance between the midpoint and an endpoint. So let me look back up at the endpoints here. We have two choices, 1, 4 or negative 3, 2. I'm going to use 1, 4. So let me write that down for reference, 1, 4. Remember, in the distance formula, we're squaring things, so it doesn't matter what order we subtract. But I'll go ahead and put the endpoint first, let's say. 1 minus negative 1, the quantity squared, plus 4 minus 3, the quantity squared. And so the radius is equal to 2 squared plus 1 squared in a square root. So the radius is equal to the square root of 5. What that means is that the radius squared, of course, then, is equal to 5. Putting together the midpoint and the radius in standard form, we get x plus 1, the quantity squared. Remember, we changed the sign on what's inside the parentheses. Plus y minus 3, the quantity squared, is equal to 5. I told you about a pitfall, so let's talk about it. Suppose we had used the whole diameter. In this case, we would have gotten that the diameter is equal to the square root of 20. The radius is half the diameter. So when we square the radius to put it into the formula, we'd have to square half the diameter. And what a lot of folks will forget is that then r squared would become d squared over 4. That 4 is what a lot of people would miss. So I think it's safer, when you're given endpoints of a diameter, to first find the midpoint and then use the midpoint to find the radius. In any case, x plus 1, the quantity squared, plus y minus 3, the quantity squared, is equal to 5, is the answer to this problem.